In this video, I'm going to go over an example of how to draw a scaled sketch for a truss bridge. The first thing that you need to know is how big you want your truss bridge to be. So for the one that we're going to do, we're going to have our length be 5.5 inches and our height be 2 inches. The next thing that you want to do is then draw a rough sketch of what you want your design to look like. There's tons of different truss designs that you can choose from. You can combine them, make your own. We're going to do one that's very simple to show how to draw the truss, because one of the most important things that when you're thinking about your design is you want your bridge to be symmetrical. Meaning, if you draw a vertical line through your design, the two halves of your bridge should be identical. The reason for that is it's going to make it more structurally efficient because the weight that's put on top of your bridge will be spread out evenly across your entire design. I went ahead and this is not to scale, but this is what we're going to design. So this length will be 5.5 inches. This length will be 2 inches. And then I just want to have 3 triangles go throughout. And I want the midpoint to be this middle triangle. So if I were to draw a vertical line through here, my 2 sides would be identical. Now I'm going to use pen in this video, but I highly recommend that you use pencil. So if you mess up, it's very easy to erase. It's totally fine to make mistakes. So I'm going to go ahead and write down the number of triangles that I am going to include in my design, which in my case is 3. Now the next thing I want to do is draw the outside of my truss. So you need a ruler. And then make sure you're not starting all the way at the end of your ruler unless that is where your 0 mark is. And I'll draw 5.5 inches. And remember, an inch is broken up into 16ths. So every little mark is a 16th of an inch. The second biggest line would be 1/8 inches. Then you have 1/4 inches, and then the one right in the middle is a 1/2 an inch. So this right here would be 5.5. Then our height is 2 inches. So here's what our design looks like right now. So this is our 5.5 inches. This is our 2 inches. And take your time while drawing this, because this is what our template's going to be to actually put our pieces of wood on top of. So we want it to be as accurate as possible for when we build. Now, the next thing we want to do is we want to put our thickness for our sides in, so we can subtract that from where our design is going to be. So if we put in our thickness of our wood on each side, then our design would have to fit in between that. For our truss, we have 2 different sizes of wood we can choose from. We have 1/8 of an inch piece, which is this smaller piece, and then we have a 1/4 inch piece. For my design, I'm going to use 1/8 inch pieces for everything, but you can use either piece, a combination of pieces, totally up to you. So for this part, I'm actually going to use a pencil to make sure my measurements are accurate. And I want to put in my thickness of the wood. So if I go to the edge and I line up my 0 mark, and then I want to mark where a 16th of an inch would be, which is 2 of these little lines. And then I'm going to put a little mark. And I want to do that in a couple different places to try to make sure that my line is going to be as straight and accurate as possible. So if I draw this in, then the thickness of it should be about 1/8 of an inch. Now I want to do the exact same thing on the other side. And then go back in and draw that line. Now, I'm not going to draw the thickness of the top or the bottom yet, because if I were to then go back and draw my triangles in, they'll come to a point. So if we take a look at this scale drawing, if this was the inside of my design, they come to a point and it actually would dig into that top beam if the thickness is on the outside. So it's better if I draw it in and then go back and add the thickness to the inside, and then it'll flatten out those pieces and it'll help make my structure stronger. So now we need the new measurement of how much space do I actually have between these two beams. Now we could measure it with a ruler, but we want to be as accurate as possible, so we're going to do it mathematically. So we need to subtract the beam width from our total length, which we know is 5.5. We're going to take a few notes. So we need to subtract the side beam width from the total length, remembering that our two options of beam width are 1/8 of an inch or 1/4 of an inch. So we're using 1/8 of an inch on each side. So we're going to have to take 1/8 of an inch, multiply it by 2, one for each side, and then subtract that value from the total length. So if we take 1/8 of an inch times 2, remember when you multiply fractions, you can put this value then over 1 and just multiply across the top. So that would give you 1 times 2 is 2. 8 times 1 is 8, so 2/8, which we then can reduce to 1/4. And then I'm going to go ahead and convert that to a decimal. In a calculator, you would just do the top divided by the bottom. So 1 divided by 4 would give me 0.25 inches. I then want to take the total length minus our beam widths, which I just found here. Before I do that, I'm going to go ahead and change the length. Right now it's in fraction form. I can convert that to a decimal to make it a little easier. So 5.5 would be the same as 5.5 inches. So I'm going to use that value, 5.5 minus 0.25 inches, which gives me 5.25 inches. So this is the actual space I have to work with. Now, the next thing I need to do is I need to take this value and then break that up into however many triangles or however many pieces of my design that I'm going to have. So in my case, I'm going to have 3 triangles within this 5.25 inches. So to help with this, I created a template that we can use to help us with the math if you find this useful. So finding the size of individual trusses, what I mean by that is like individual triangles, or maybe you first need to find some rectangles and then break those down into triangles. So we need to take our beam length, but this is going to be like the beam length that we have to work with. So our total beam length was 5.5, but we actually have 5.25 inches that we're going to work with, and divide it by the number of pieces. So in our case, it's the number of triangles. So we're going to take 5.25 divided by 3. And then if I put that in my calculator, I get 1.75. Now, the reason I made this is because it can get kind of messy. Like 0.75 is a pretty clean decimal, but you could get anything. Like you could get 1.833333 or something like that. And then this template will kind of help you figure out, well, how many 16ths of an inch does that break down to? So once you have this value, you're going to take the whole number part of it. So the 1 is going to go into this box. And then I'm going to take the decimal portion to this side. So then I can then convert it into 16 of an inch. Then I'm going to take 0.75 and I want to multiply that by 16. And then we're going to write the new number over 16. If it's a messy decimal, then round it to the nearest tenth. So if we take 0.75 times 16, it's nice and clean for us. So we're going to get 12 over, and then remember the denominator is always going to be 16 because an inch is broken down into 16ths. Then we just bring these two pieces together. So the length of each of our triangles is going to be 1 and 12/16 of an inch. This is going to tell us the total width of our triangles. We could also simplify this. So 1 and 12/16 is the same thing, as 1 3/4 inches. So this is going to give us the total width of our triangles. The next thing that we'll need to do is then find the halfway point to find the top of our triangles, but let's go ahead and mark the base of our triangles using this. So 1 3/4 inches. And I'm going to line up my 0 with that inside beam. And again, I'm going to use pencil for now, and I'll come back in marker to make it a little bit clearer, but I'm going to go to 1 inch, and then I need 3/4, or you could count 12 of these, but remember the 1/4 inch mark. So here's 1/4, 2/4, 3/4, so it'll be right here. And then slide it over. Again, if I mark it 1 3/4, should be right here. So we then want to check that the last one is really close to 1 3/4 as well. I'm also going to mark the top at these same locations because it'll make it easier when I go back to find the midpoint. So like right now, my triangle should fit in between here. And so what I need to do then is go and find, well, where is the midpoint to show like where's the top of my triangle going to meet. Okay, now I'm going to go back to my template, and I want to find what's half of 1 3/4. So I'm going to use the 1 3/4, convert that back into a decimal, or you can work with fractions if you want. So 1.75, which I got from these two pieces, and divide that by 2, which will give me 0.875. And then because I only have the decimal portion, I just then need to multiply that by 16, which will give me 14. And then that's out of 16, so 14/16. Or we could reduce that to 7/8. So what this tells me is if I start at the beginning of the triangle, and I go over 14/16 or 7/8, that'll give me my midpoint to where my triangle is going to meet at the top. So let's go ahead and do that. And I'm going to make these lines a little bit longer so then I know which ones I can go back and erase. So if an inch is here, I just need to go back 2/16. So my halfway point is right about here. And then I'll go to the next one. 14/16 is about here. So what this shows me is, so here's the midpoint of my first triangle. So it should go up and then down, up to here, back down, up to here, and back down. So these marks can be erased so I don't get confused. And now I'm going to go back and go ahead and draw in my 3 triangles. Once you draw in all 3, it should look like this. I now can go back and put in the thickness of my top and my bottom beam, and then I'll go put the thickness of my interior triangles. So all my pieces are 1/16 of an inch. So remember, line it up and then put a couple marks across to show where the beam's gonna run. Once you've done that, then you can connect it. I like to put 3 or 4 just to try to make sure that my line is as straight as possible. I'm then gonna do the same thing on the bottom. Now, in my design, I want this top beam to be the full piece all the way across and the bottom beam, and then use these vertical beams as support. So what I'll do is extend these all the way to the edge and then go back and erase. And then I can erase all the interior triangles. And then I'm going to go over my outside in marker just so it's a little bit easier for you to see what I'm talking about. Okay, so I went back and I traced everything in marker and I put the thickness all the way on the outside. Now I need to go and put the thickness on my interior beams. You can choose whether you want to put the thickness on the inside or on the outside. I'm going to put mine on the outside because I have some gaps where it's not touching my outside beam and my interior aren't fully connected. So if I put it on the outside, all of that will then connect and make my truss stronger. What you want to do is put your ruler at the angle of the line and find where it's going to be a 16th of an inch. So 1, 2, and then put a couple marks following that angle. Once you finish adding your thickness, this is what your truss should look like. After going back over my lines and marker, it was starting to look a little bit messy, so I just went ahead and shaded everything in. That's why it's better to use pencil than marker. One last thing I wanted to point out is since we added the thickness of the beam afterwards to the top and bottom, these are flattened out as opposed to coming to a direct point, which would dig into that top and bottom beam. This spreads the load out a little bit further with them being flat on the top and the bottom, which will then make your truss stronger.